Hey guys, we're up to the last exercise in chapter 6, which is applications. Uh, with applications, there's a few tips that I have down here for you guys. I've shown them to you before. I'm not going to read through all of them, but it's a good idea to make sure you're paying attention to them because I think a lot of us do have a bit of trouble when it comes to application questions, and these tips might help you out a little bit. It is quite difficult to teach them like as a whole because some of the questions are really different. But the questions that I have right here, they're not too difficult. It's more so just to wrap your head around a couple of concepts. So let's get into the first one. All right, so we've got a wheel mounted on a wall, and it rotates such that the distance d in centimeters of a particular point P on the wheel from the ground is given by that rule there, where t is the time in seconds. That might be a little bit of a mouthful. You might need to think about that for a second, but I'll quickly show you something. So it's pretty much this situation here. You've got a wheel on the wall. I know this is just a fan switch, but here's your wheel on the wall. And it's talking about the distance of a certain point from the ground. So let's just say this off section. It's like the wheel's rotating at a constant pace, and we're just seeing how far off the ground that little off word is. So as you can see, it starts off close to the ground and then gets further away, but then as it spins, it gets back to its original spot. So this is the situation that we're talking about. All right, so let's get into these questions. Right, now question A, how far is the point P above the ground when t equals 0? So when t equals 0, that's right at the start. What we're going to need to do here is make t equals 0, and that's going to help us find the distance, isn't it? So let's take that rule, make t equals 0, and see what we end up getting. So I'll make t equals 0. If I make t equals 0, this times 0 is 0. So that gives us cos 0. Cos 0 is, hopefully you can remember from your exact values table, cos 0 is 1. So our answer is going to be 100 minus 60, which is 40. Now, I'm not just going to leave my answer as 40, because it says how far is the point P above the ground. We need to give the units of measurement. So if you look up here at the question, D is measured in centimeters. So at the start, that certain point is 40 centimeters above the ground. All right, let's move on. So B, how long does it take for the wheel to rotate once? We're pretty much just being asked what the period is here, isn't it? Because we just want to know how long it takes to get round to where it started. So it's going to start at 40. We want to know how long it takes to get back to 40. So, because it's a cos graph, it's going to finish where it started. So the start of the period is going to be the same point as the end of it. To find our period, we need this rule here. So 2 pi on n. Our n value is 4 pi on 3. And if you work this fraction out, it's going to become 3 on 2. There we go. So it's going to take 3 on 2 what? So we need to make sure we're having a look at our question and giving it context again. And it says that t is the time in seconds. So 3 on 2 seconds, or 1.5 seconds. Cool, we've done that one as well. All right, question C. Find the maximum and minimum distances of the point P above the ground. Well, we know that it started at 40. We want to see how high and low it goes. Now, given the rule, if you can read this rule, hopefully you guys can, because we've had a few exercises where we've practiced using these rules. We should be able to recognize that it starts off at its lowest because we've got a negative cos graph, then goes up to the top, and then comes back to the bottom. But, to be honest, we don't really need to know that. All we're being asked here is the range. So to find the range, you've got your average, which is 100. got your amplitude, which is 60. So it's going to go 60 higher than the average, and it's going to go 60 lower than the average. Okay, so we could say we've got 100 plus minus the amplitude, which is 60. That's going to give us 40, and it's also going to give us 160. So these are our highest and lowest. So the minimum is 40 centimeters above the ground, and your max is 160. Cool. All right, now D, we're just revising our graphing. It hasn't given us a domain to graph it, so I'm just going to assume that they want us to graph it for one cycle. Every time it's in a SAC or in the exam, they're going to tell you the exact domain they want you to sketch it over. But for now, we're just going to sketch one cycle. And when we sketch it, we need to make sure we're showing, well, we need to be nice and organized. So I'm going to show that my average is 100. My amplitude is going to be 60. And my period, which we worked out before, is going to be 3 on 2. Let's set up our axis. Okay, I've put all my numbers in there to help me sketch, well, not sketch, but set down those grid lines. I need to label these axes as well. So now we're not talking about Y and X. We need to show what it's actually representing. So this here is time. So I'm going to call it T, as we have in the rule, and it's measured in seconds. And here is distance above the ground of that certain point. So I'm just going to say it's distance. So D, and it's measured in centimeters. There we go. All right, I'm going to put those guidelines in and then start sketching. Cos graph would normally start up the top, except if we have a look at the rule up here, it's negative. So instead of starting at the top, it's going to start down the bottom. Halfway through, it gets to the top. And then right at the end, it gets back to the bottom. All right, there we go. Now we can also see any key points that we need. So there's an endpoint here. We can see that that's when x is 0 or t is 0, and d is 40. There we go. We can see that there's a maximum here. So that's when x is 3 on 4, and your y, I'm choosing x and y because it's easier for me, and we've got another endpoint here. Your x is 3 on 2 and your y is 40. There we go. There's not really any other key points that we need to show at the moment. Let's go down to E. Okay. So, E, in the first rotation, find the intervals of time where the point P, so that's the specific point that we were talking about, so our graph shows how far that point is from the ground, when it's less than 70 centimeters above the ground. Now I'm going to show that in our graph here because I think that's an easy way to sort of go about it. So 70 would be about here, wouldn't it? Something like that. Halfway between 40 and 100. So that's 70. And I'm going to show the line of 70, which is that line there. Now, if we sketch them both as we have done just here, it shows where that point is going to be above 70, and it shows where the point's going to be below 70 in these sections here. Now it's asked for, find the intervals of time where the point P is less than 70. So we're after these times and these times as well. To find out those times, we're going to have to work out these intersection points because the time's going to start there and end there, but then there's another bit where the point P is lower than 70. That's going to start here and end there. Okay, now it has to all be in the first cycle. We know this keeps going, but it's specifically spoken about the first cycle over here. Let's try to find these 2 points. We've got our rule. There we go, we've got our rule. But we want to know the time when the distance is 70, because that's going to show us those 2 points there. So I'm going to change distance to 70. Okay, there we go. Normally with these sort of questions you are going to be able to use your CAS, but let's just do it by hand for now, just for a little bit of practice. We can use the CAS a little bit later. Alright, I'm going to get rid of my 100. There we go. If we divide by 60, that's going to give us 1/2. Negative 60, I should have said. Alright. Now we want to solve for this t, don't we? So we're going to set this up. We want the angle where our cos length is 1/2. Now we're just talking about the first rotation or cycle. So we'd be talking about, let's see, to be up there, which is pi/3, and it would also be down here, so 5 pi/3. Okay, now if we're trying to solve for t, we're going to end up getting, and I'm going to move it over here because I don't have much room. So we're going to divide both of these things by 4 pi on 3. Yep. And that should give us pi/4 and 5 pi/4. Okay, so we worked out that this point here is where x is pi/4 and your y is 70, and this point here is where your x is 5 pi/4 and your y is 70. So we can see that this bit here, it's below 70, and this bit here, it's below 70 as well. So if we're going to give our answer, we could say from time 0 to time pi/4. It doesn't include pi/4 though, because pi/4 is at 70. We're after below 70. But also we have this section here. So that's from 5 pi/4, and it doesn't include that either because that's on 70. We want below 70, and we're going to finish at the end of our cycle, which is 3 on 2. And it does include that. Cool, there's that question. Now with this second example, I'm not going to do the whole thing in this video because I want you guys to spend time doing different questions. This one is quite similar to the first one. So I want you to try and do it by yourself. I will give you the answers right now though. So maybe pause this, have a go, and then start it back up when you're ready or you want to check your answers. Okay, so it's a different kind of scenario. We're talking about how deep water is. So we've got, I think, what does it say? Average or mean sea level on a certain day. So the first thing it asks is to sketch the graph, and it tells us to sketch it over the domain from 0 to 24. What you'll find out is that the period is actually 12. So that means you're actually going to be doing 2 cycles. So in this graph, you can see you've got 1 cycle of your graph and then a second cycle. All right. The other question only had 1 cycle, but this time you're drawing 2. The next question B, when was the high tide? We can see by looking at the graph that the water is at its highest level at these 2 points here. So it's when T is 3 and when T is 15. I've changed this to just your normal 12-hour time. So you've got 3 a.m. because it spoke about hours after midnight. So 3 a.m. and 15 would be 3 p.m. So 3 a.m. and 3 p.m. are our high tides. It also asks, what was the height of the high tide? We can see that at those times, the depth or the height of the tide is 4 meters, which I've put in there. All right, now it asks for the height of the tide at 8 a.m. Now 8 a.m. is somewhere around about here, so it wants the height of this bit here. So it's going to be in a negative. So all we needed to do was sub in 8 for 8 a.m. and you're going to work out that that is the height there. And it makes sense because it's a negative and we've got a negative down here. All right, now E is the hardest one of the lot. Again, it's really similar to the last question in our previous example. We want to work out when the tide is at least 1 meter above sea level, because that's when a certain boat can get in. It must need that depth. If it's less than 1 meter, it might scrape on the ground or something like that. So let's look at our graph. We want to see the times where the tide is, the water level is greater than 1 meter. So we can see that this part, it's greater than 1 meter, and this part, it's greater than 1 meter, because it's above that line that I've put in that represents a height of 1 meter. So these are the times that we're after. Okay, now if you substitute in a depth of 1, you're going to end up having this. Now this isn't an exact value from our table, so you know we can't, well, easily anyway, find out the value for T without using our CAS. So that's what I've done. I've sketched this graph. I've sketched my T equals 1 as well. And then I've found the intersections. Okay, so I've found this one, this one, this one, and this one. And those at these times, so 0.483 and so on. Now what I've done here is change those times to our 12-hour times. So 0.483 would be 12:29 a.m., etc., etc. So we need to recognize that between this one and this one is when the boat can come in, and between this one and this one is also when the boat can come in. So we could say from 12:29 to 5:31 and from 12:30 p.m. to 5:30 p.m. All right, those 2 examples are done. Now we'll try these past exam questions. All right, so in this one we have a cos rule, a sine rule with an unknown a, and they have a point of intersection where x equals pi and 3. So x equals pi and 3 is common to both of them. And if they're intersecting, we can make both rules equal each other. So that means we could have cos pi and 3 is going to be equal to a sine pi on 3. Alright, once we solve these two here, we're going to be able to solve for a. So cos pi on 3 is 1/2. And sine pi on 3 is root 3 on 2. There we go. Which will then give us 1 equals a times root 3. So a equals 1 on root 3. Which is the same as root 3 on 3, but I'm just going to leave it like that for now. So that's a. Now look at b. Alright, now we're thinking about these two graphs still over this domain. Find the coordinate of the other point of intersection. So they're telling us they're going to hit again over that domain. They're going to hit at this point, but we want the other point as well. Alright, so to find out where they intersect, we're going to make both of these rules equal each other. So we could have cos x equals, remember a is 1 over root 3, I'm just going to leave it as that one, sine x. Alright, now we're solving for x here. We've got a sine and a cos, so we're probably going to end up needing to use this rule to solve for it. Really important rule, make sure you remember that. Alright, now I'm going to start working up here. I might move this sine over, so I'll divide both sides by sine x. Alright, now can we see how this rule here, more specifically this bit, looks similar to that, except it's the other way around? We've done this before. We can actually just flip them. So it's the same as this, sine x on cos x. You can't just flip one side of your equation, you've got to flip the other one as well. So the other side is going to be root 3 on 1. You just write root 3. Alright, now look at this. We've got sine on cos is equal to tan. So we have tan x equals root 3, and we're solving that over the domain we were told at the start, which is from 0 to 2 pi. Alright, awesome. So if we want to solve for x, and over that domain here is going to give us pi on 3, which was the other answer before that we had at the start. And also the other one's going to be 4 pi on 3. There we go. So our answer is that just there. Alright, now let's move on to this next one. Now this can be a little bit confusing with what's going on here. Alright, so a function f has the following two properties. Now they're sort of talking about equivalent angles here. See how we've got theta there, and they equal theta there and theta there as well. Let's try to break down what it actually means. That's why I've got these written down there. So in this case, theta's only going to be anything between 0 and 90 degrees or pi on 2. So let's have a look at what this actually means there. So let's look at where pi is. The pi is here, and you're taking away theta, whatever degree or angle that is. It's going to have to be this. So it's in the second quadrant. Okay, and this one here, like that same angle, but it's in that first quadrant. Okay, so it's whatever theta is going around that way, and it's got to be within 90 degrees, so that's why it's there. Now over here, that's the same as that one. So that's second quadrant. And this one here, that's going to end up being fourth quadrant, because if you're going a negative angle, it's going this way, isn't it? So it's going to have to be there. Alright, now I just want to write a couple of sentences about what these actually mean. So we could we could say that for a function, for this function, the second quadrant value, which is this bit, second quadrant value, it has an opposite sign. You see how this one is like positive and that one's negative? It has an opposite sign to the first quadrant value. Okay, so there's one piece of information that we have. Now let's look at this one. This has to be true for the function as well. So for this function, the second quadrant value has positive sign, negative sign, has the opposite sign to the fourth quadrant value. All right. So this has to be true. These two things both have to be true for whatever function it is. Now, these are the functions that we can choose from. All right. Now, it's talking about having the same sign or a different sign, so being positive or negative. I'm going to remind you guys of where each of those sine, cos, and tan are positive and negative. So for the first quadrant, our sine is positive, our cos is positive, and our tan is positive. For the second quadrant, our sine's positive, cos is negative, tan is negative. For the third quadrant, our tan's negative, our cos is negative, our sine's negative, our cos is negative, and our tan's positive. And for the fourth quadrant, we have sine as negative, cos as positive, and tan as negative. Okay, now let's look back at these sentences here. For this function, the second quadrant value has the opposite sign to the first quadrant value. We're looking at the second quadrant values first. Which ones have the opposite sign? Sine doesn't have the opposite sign, so that's no good. Cos and tan have the opposite sign, so it could actually be one of those. I'm going to cross this sign out for now. So it could be either of those, but this has to be true as well. For this function, the second quadrant value has to be the opposite sign to the fourth quadrant value. Remember, we can't have sign. Cos is opposite, tan's the same. Tan's no good. So that means it was true for cos. So our answer must be this one here. So our answer must be B. Now that was a little bit of a confusing one. You can sort of do that through trial and error on your CAS as well if you don't understand what happened just then. If you don't understand, ask me and I'll show you the other way. Now this one here I think is definitely easier on the CAS, so I'm going to show you a CAS video after this. Let's move down to 64. Now this is super similar to what we were doing just then with applications. Those other questions were more so just thrown in there randomly, but this one is quite specific to what we were doing just before. Alright, so we've got our rule here, and it's talking about the depth of water again. H is the depth and T is the time, so depth compared to time. Find the minimum depth of the water, or the minimum height because it's used H. we don't have to sketch a graph of this at all. We can see that the average is 14 and the amplitude is 8. So that means from 14 it's going to go up 8 and that's going to be the highest, and from 14 it's going to go down 8 and that's going to be the lowest. So the minimum depth is going to be 14 and then take away that 8. So that's going to have to be 6 meters is our minimum depth. So A was pretty quick. Now let's have a bit of a look at B. Alright, so find the values of t when the height is 10. We can put that height is 10 into our rule here, and then t is going to be the only unknown, so we're going to be able to solve for that. So let's make the height 10. Alright, cool. If I take that 14 away, that's going to give me -4 over here. Oh, I forgot to write sign. There we go. If we divide by 8, that's going to give us -1/2. Alright. Now, we want to know the values where it's 10, except we've been told that the time is only between 0 and 24, but I can actually work out how many cycles this is going to go through. So I actually need to work out what the period is, because I might have to go around 2 cycles rather than just 1. So I'm going to have to check that first. So to find the period, remember it's 2 pi and n. Pi on 12, and that is going to give us 24. So it's only 1 cycle. The period's 24. We've been told that this rule is applicable over that domain, which is from 0 to 24. Alright, so when we're solving this, we only need to do 1 cycle. Okay, so over 1 lap of the circle, the solutions to that are going to be, let's see, 7 pi and 6 and 11 pi and 6. Cool. Alright, now we just need to solve for t, because we've got all this other stuff as well. So we need to times by 12 and then divide by pi. So t is going to end up being, that one will turn into 14. Oops, you can't see. That one will turn into 14. And that one will turn into 22. So there's your answer for B, and there's your answer for A. Alright, now I am going to go back to this one, except the easiest way to show you is on the CAS. Alright, we'll finish off by doing question 48 by using our CAS. So you've been given a rule there. I've actually sketched that rule, and it's telling us that it has an inverse function, but we want to find out what negative A and A are, so pretty much we want to find the value of A. Now, something that isn't said here, but it's an important piece of knowledge that we have to know, is that for there to be an inverse function, the function, the original one that we have right now, has to be 1 to 1. So as you can see with what I've sketched here, this isn't 1 to 1 at the moment. We're going to have to restrict this domain so that it is 1 to 1. Now, if you look at the domain that you've been given, so from negative A to A, it's telling us that with the domain that we kind of come up with, it has to have an equal distance from the y-axis going in both directions. Now, I'm going to get you to follow my cursor here. Can you see? I'm just going to start at the y-axis here. Can you see if we follow the graph here and go past this turning point there, it's not going to be 1 to 1 anymore. So that's not actually going to work for us. And if we go the other way, if we go past this little turning point here, that's not going to be 1 to 1 for us either. So the furthest distance in this, the furthest distance in this negative direction we can go is actually wherever this turning point is here. Now this this notch little here, this little notch that we have here, God, it's going on everything. This notch that we have here on the x-axis, that's actually pi on 6. So it looks like this turning point is a bit less than pi at 6. It's about halfway. Now, if we look at our options, so A, B, C, D, and E, half of pi on 6 is pi on 12, which is A. So it looks like that's going to be the answer. But let me actually restrict this domain on the graph so we can see it a little bit better. So I'm going to put a domain in here. So I'm going to make it pi on 12 so we can actually check. I'll make a pi on 12, I should have said. Okay, so I've restricted it there. As you can see now it's 1 to 1, so it is going to work. So A is going to be our answer. Let me just put in another one just to show that it doesn't work. So let's use pi on 6 instead. So I'm going to make A pi on 6. So if A is pi on 6, that will make our domain this. You see how it's not 1 to 1 anymore? Okay, so if you do a line through there, it's many to 1, so that's not going to work, so it's going to have to be A. Alright guys, have a look at those questions listed at the bottom of your notes. If you've got any questions, make sure you ask your teacher.